Hey everybody, thanks for clicking on this video. Now this is the fourth in a four-part series on Riemann sums. So if this is the first one you're doing, I recommend you stop. Start with the left-hand Riemann sum, that's part one, and then go through the four parts. Because I go to a little more detail, I take it a little slower with the first few, and then the third and fourth one, I go a little faster just because it's the same problems all over again. The only difference is we're doing midpoint in part three and trapezoid in this one on part four. So here we have again the graph of x squared. I want the integral from -4 to 4. And we're breaking this up into 4 subintervals. Now instead of rectangles, they are trapezoids. So what that does is that splits the difference between the height on the left and the height on the right. So in a sense, what you're doing is you're just connecting the left and the right with lines. Just like that. So we have n is 4, the width is 2. So the way we calculate a trapezoid is we just average out the heights of the two ends. Now the width for all of them is 2. So we have 16 and 4. So I'm going to average those. Then I have 4 and 0. And then over here I have 0 and 4. And then I have 4 and 16. Now, if I simplify that, that's 10 plus 2 plus 2 plus 10. And so when we calculate that, we get 44 for that Riemann sum. For the second one, here we're doing 8 subintervals. So we're going from -4 to +4, and we're breaking all these up. All right. And so they all get connected with lines. Now, we have 8, and they all have a width of 1, so I don't really need to multiply 1 times all these heights. And it's going to be a little cluttered writing them all, but want to make sure that you see them all written out. So we go 16 and 8, or 16 and 9 for the first one, and then 9 and 4 for the second, and then 4 and 1 for the third, and then 1 and 0 for the fourth, and now it just reverses. 0 and 1, 1 and 4, 4 and 9, and 9 and 16. Now what's nice is, if you notice, 16, 9, 9, 4, and all that, they just show up twice. So this all simplifies to just 16 plus 9 plus 9 plus 4 plus 4 plus 1 plus 1. So that's 20, that's 16 and 28. And so that's going to be 44 is what we get. All right. Next one, here we want to find the trapezoid from -3 to +1, 2 subintervals. So I connect here and I connect here. In this case, it actually turns out to be a rectangle since the two ends are the same. I have 2 subintervals, each of them with a width of 2. So we have 2 times, let's average these, 9 and 1, and 1 and 1. So 2 times 5 plus 1, and we get 12 for this trapezoid. So number 4, here we want to estimate with trapezoid with 2 subintervals. So first we go from 0 to 60 and 60 to 120. So now we do 1.2 plus 4.7 over 2 plus 4.7 plus 4.8, because those are our two ends for this one, over 2. And when we calculate that, we get 462. Next, we have 1, 2, 3 subintervals. So this is going to be 1.2 plus 4 over 2 for our first interval. Then for our second interval, 4 and 5.1. And then our third, 5.1 and 4.8. When we calculate all that, we get 484. And then finally, we have all 6. All of them with a width of 20. So 1.2 plus 2.8 over 2. 2.8 plus 4 over 2. 4 plus 4.7 over 2. 4.7 plus 5.1 over 2. 5.1 plus 5.2 over 2. 5.2 plus 4.8 over 2. And when we calculate that, we should get 496. Now, I wrote them all out. Some teachers want you to do that, but some teachers will also teach you that you can find the trapezoid approximation if you find the left and the right with equal number of subintervals. You just average them. That's another way to do it. But I don't know what your teacher or your textbook demands, so I wanted to be sure that I got you into the habit of writing them all out. Thanks for watching. If you liked this video and if it helped you out, please give it a like. Or if you want to see more, go check out the other videos on that channel and hit the subscribe button. Thanks for watching. Remember, the best way to understand something is to do it.